this is involved with more calculation, but we kind of deal with this problem before in the actual first week or second week of this class. And stoichiometry is essentially talking about this way. And let's just looking at this equation first. This is Ag plus and chlorine minus. If you have those in the solution, they're going to form AgCl as a solid. And the chemists sometimes they just write it like arrow down here, which means a precipitate. They became insoluble products and they kind of settle down in the reaction. And then you will start to see that where is this chlorine is coming from? This chlorine is coming from FeCl3. If you start to read the one, they say how many milliliters of iron trichloride with this concentration solution and how much do you need? And where's the Ag plus is coming from? You guys see that AgNO3. So now you start to see that each one has its own origin. AgNO3, and they're producing this. And when AgNO3 produce an Ag plus, they make the NO3 minus, and they make Fe, I guess a 3 plus, and they're what we call the spectator ion. Have you heard about that? Spectator ion? They're just spectators. They're not in the part of the action, quote unquote, which means a precipitation. Okay? So these are the action actor item, I guess, and there is something that's doing nothing, which is a spectator ion is there. So when you have these two, as soon as you do that, chlorine meets the Ag, and we saw the insoluble precipitate, and that's an understanding that I have before I actually go to the calculation. So now let's read the problem. Okay, so how many milliliters of this solution is needed to react completely 20 milliliters of AgNO3 of this concentration? Okay, so all you gotta do is, you remember this is the diagram that I discussed with before. You know, what do you want? I want how many milliliters of this solution, and where do I start? I guess I start with this. Okay? So I'm going to start that. So keep that all the problem in here. So okay, I'm going to write down the 20 milliliters. So milliliters of AgNO3, and this is, I just put an annotation that this is actually the solution, and so that what I want to write here is, because it's a solution, I want to write the solution. Later I can shift my focus to a new quantity and I can continue to do it until I got the solution of AgNO3 or solution of FeCl3 solution at the end. Okay? So I start with the AgNO3 solution, and then the AgNO3 1000 ml, which is a 1 liter, there are 0.054 moles. Okay, so all of a sudden I changed my interest from solution volume to number of moles, which is the first step. And then the AgNO3, and I want to know the AgNO3 produce Ag plus. So that's what I can write down here. And Ag plus will react with Cl minus. So I'm going to write so that you can keep on canceling out and then develop something that is what you want. And particularly the most important step is this step, because this step is coming from the reaction that what we wrote here. Okay? So because of that, I'm using the chemical reaction information. Now finally, I mean, I don't really need a step. If you guys figure that out, it's already okay. This one produce Ag plus, so I can just put Ag plus Cl minus. So if you need to do, you can do, or you can just go skip and just write this way. But this is essentially switching the compounds of interest to Cl minus, and now is a Cl minus. Okay, the Cl minus And then what I wanted is FeCl3. And the ratio between is 3 to 1. So that's the one that you're going to write. So then now the shifting the interest from chlorine to FeCl3, and the moles of FeCl3 to the volume is, right, so you can find from the solution. So this is the concentration, moles to the volume of the solution. So by doing so, you can continue to eliminate, shift your focus to something that is new. So this is what I have been doing this. And finally, what I have is FeCl3 solution of that particular concentration. Right? So therefore, and then you wrote it this, and then it comes down to simply down to 20.0, 0.054, 1,000, 1 over 1, 1 over 1, 1 over 3, 0.150,000. So then you will see have an ml of something. In this case is FeCl3 solution. And then this is a number that you will get by plugging those numbers there. So it's always this unit conversion is trying to put something that is an equivalent on both sides as defined by the concentration or defined by stoichiometry. This is a stoichiometry base, and this is essentially reaction as defined by the reaction. And you choose the one that you really need to use. I have a second example, which is how many grams, okay? How many grams of AgCl will be formed? In that case, I need to look at the periodic table, look at the atomic mass of Ag and atomic mass of chlorine. If you add them together, there will be a 143.32 gram per mole. And then I'm going to start from here. So what I want is how many grams, so I guess I need a grams. So this is what I want, and then given that the problem was, once again, this is you start with the 20 mLs of those solutions. Okay? And this one is actually shows another step, which is skipped before, and I don't know why they do this way, but you can say, okay, I don't like milliliters, let me change the liter. Milliliters are gone, liters. So they changed the liters to the liter so that they can essentially, they could have just write 1,000 milliliters in the begin with. This is what they did. Anyway, so now using the concentration, I deal with AgNO3, number of moles, and this, and then looking at the reaction, what I want is AgNO3 and AgCl now that is reacted from AgNO3, and it's a 1-to-1 correspondence because AgNO3 produce Ag plus NO3 minus, and this one essentially react with and become AgCl. So it's a 1-to-1 stoichiometric ratio, so I can put that in. And then this is now I know how many number of moles of AgCl can be produced, and from the number that I learned is a 143.2. This is a gram. And then everything goes away. You ended up having grams of AgCl at the end. So this is the answer that you've been looking for. So once you do that, I always like to kind of put things without all the notations. So this is a 1/1,000, changing the milliliter to the liters, and then the 1 liter contains so many moles of AgNO3. And the moles of AgNO3 to AgNO3 mole is 1-to-1 ratio, and 1 mole weighs 143.42 grams. And that you have. precipitate. Okay? So that's the way that I can solve this equation.